Hello, everyone. My name is Kasirzadeh. I am a philosopher and a mathematician at the University of Toronto and Australian National University. Today, I will present my paper titled Reasons, Values, Stakeholders, a philosophical framework for explainable artificial intelligence. As we all know by now, governments and private actors, to varying degrees, are using machine learning algorithms in order to resolve different critical decision-making problems in domains such as hiring employees, assigning loans and credit scores, medical diagnosis, and criminal recidivism. Despite their predictive accuracy, many of these algorithms are opaque. This means that it is difficult for humans to understand why an algorithmic outcome is obtained. As you see, this definition of opacity or epistemic opacity, I use these two terms interchangeably, is very general and broad. I have highlighted three terms difficult humans understand in this definition, and my hope is that by the end of the talk, these notions would become much more clear, and therefore this definition would be more precise. For now, let's adopt this broad definition. One important question that arises then in this context is how this opaqueness should be handled. There are many different solutions and different responses to this question. I don't have time to review all of them, but today I will focus on one of the most promising and highly discussed proposals, that is the solution of explainable AI. The idea here is that if there is this opaqueness problem, then maybe we can design some explainable systems that they explain why a particular outcome is generated. This topic has been discussed since 1980s in relation to mainly non-machine learning artificial intelligence systems. But since 2016 and this very huge, interesting DARPA project in the United States, Expandable Artificial Intelligence or XAI, the topic found a new revival, and many different academics, industrial bodies, and organizations focus on examining different aspects of an explainable artificial intelligence system. So yesterday I searched for explainable artificial intelligence in Google Scholar, and I found 41,500 papers. This shows how increasingly popular this topic is. One point of clarification is that in the talk today, I use the terms explainable artificial intelligence, explainable machine learning, interpretable artificial intelligence, and interpretable machine learning interchangeably. Now, the basic idea or a difference between an explainable algorithm and an opaque algorithm is that an opaque algorithm only generates an output, whereas an explainable algorithm generates the output, but also the reasons for why this output is generated. So, for example, consider a machine learning algorithm that is based on a deep neural network structure, and this algorithm is trained to learn to classify the images of different animals. Now, a new image of an animal is given to the system, say an image of a cat, and if this system is an opaque algorithm, it just says the output. It just says that with, say, 95% confidence, I predict that this is the image of a cat. Whereas if the system is explainable, it says that with 95% confidence, I predict that this is an image of a cat, but also gives some reasons why the system has thought that this is an image of a cat. For example, the composition or a special composition of different facial features and fur structure or tail has made the system to think that this is a cat rather than, say, a fox. So originally, the problem of opacity of algorithms, in the more recent context, arose because the machine learning algorithms incorporated a very sophisticated, mathematically and computationally untouchable kind of architecture, such as deep neural networks, and untouchable to human understanding. And this means that there were different architectures, for example, a deep neural network with tens of thousands of nodes and dozens of hidden layers. And then when this algorithm was being trained or was predicting a particular outcome, the smartest computer scientists or mathematicians would look into how the algorithm is mathematically and computationally behaved, but we're not able to say in very simple terms or non-mathematical, non-computational terms why the algorithm is generating this particular prediction. But slowly, when the literature on explainable AI started to develop, the issue or the topic of explainable AI found other non-technical dimensions, in particular some social, legal, and ethical dimensions. And what do I mean by that is that the scope of the promise of explainable artificial intelligence started to encompass some of the following social ambitious purposes. Like, if you have an explainable artificial intelligence system, then we might be able to increase the societal acceptance of prediction-based decisions. We might be able to increase the social trust in the results of these decisions. And we might be able to prevent the sources of algorithmic discrimination. And some people even have argued that maybe we need to consider a right to explanation for those subjects that are impacted by the prediction of an opaque algorithm. And one way to make sense of this right to explanation is to say that we would have or we would design an explainable artificial intelligence system, and this system is going to explain why this particular decision is achieved. So then, if that is the case, the receivers of explanations go beyond mere computer scientists and mathematicians that I talked about in the previous slide. So let's adopt this very general conception of explanation in order to include these different social, ethical agenda that in many cases are attached to the goals and the ambitions of the development of explainable AI. Now, the question that I'm going to examine in the paper is, what are these explanations and who are the receivers of them? In particular, I'm going to offer a philosophically informed framework for artificial intelligence explanations in the rest of the talk. And then I'm going to argue for the usefulness of this framework in an appropriate bridging of the technical and ethical aspects of algorithmic decision making. Let's start with a simple example. The example is very caricature and very simple, but just to convey some intuitions. A machine learning algorithm sifts through several job applications to recommend a hire for company X. And in particular, the job applications are kind of summarized in a person's CV. Nora is a competent candidate. She applies for the job. Her application gets rejected by the algorithmic decision or algorithmic prediction. Now, we want to know why this prediction is made. So in practice, when we are dealing with this algorithmic decision-making system or predictive algorithms, we are really dealing with a very sophisticated system that includes training data, there's a learning process, there is a learn function, there are some new inputs about Nora or any other candidate, and then there's an outcome that reflects the prediction of the algorithm. So when we are asking this explainable, when we are asking for explanations, indeed, we are facing these different bits of this algorithmic decision-making that impact how an algorithm is designed, how it is governed, and how it thinks and reasons. So I'm going to talk about two main different kinds of explanations that kind of relate to this feature or this figure of machine learning algorithms, this caricature figure of machine learning algorithms. And the basic intuition behind introducing these different kinds of explanation is to say that each of these elements, machine learning elements that you see in this figure, they kind of produce partial reasons for why this prediction is made. And so if we are adopting this broad, socially relevant desiderata for having an explainable artificial intelligence system, we need to consider all of these reasons or kinds of reasons into account. Not for one audience, as we will see, but in general. So for now, my discussion is general. And towards the end of the talk, when you see the details of the framework, you see that, okay, we can narrow down and talk about the questions more specifically. But it's always good to start from a general standpoint and then narrow down. So the first kind of explanation that are related to explainable artificial intelligence, and many explainability methods actually try to extract some kind of information. I call them feature-based token explanation. And these are explanations that try to find some dependency relations, or basically try to give reasons in terms of some dependency relations between some input features and the target features. So for example, there could be, so these dependency relations that I talked about can be cashed out in different ways. We might have correlational explanation. For example, in case of Nora, the system can say the rejection recommendation is correlated with Nora's longevity at her previous workplaces. Or it could be a dependency relation of the causal kind, therefore a reason in terms of causal explanations. The rejection recommendation is caused by Nora's longevity at her previous workplaces. Or it could be a counterfactual explanation. The rejection recommendation and counterfactually depends on Nora's longevity at her previous workplaces. Or it might be an example-based explanation saying that consider, like the system considered the whole pool of applicants and Esther was chosen rather than Nora. And one main reason is that she has a very similar CV to Nora, but a longer job longevity. So all of these kinds of explanations, also, although they characterize as dependency relations in different terms, they kind of point to some specific input features and target features. In this case, the acceptance or rejection prediction for Nora. And then finding that particular kind of dependency relation and then associating that with the reasoning of this sophisticated system might be a way to capture a reason or to give a reason for why this decision is made. One thing to clarify here is that also there are many different discussions about whether causal explanations are counterfactual explanations or whether they're different, and whether all of them, and whether, for example, example-based explanations also are a kind of counterfactual explanations if we assume that all explanations are kind of contrastive. But this is not the purpose of the talk here. So here the goal is just to say that we have different kinds of feature-based token explanations. They're token explanations because they give explanations about a very particular specific scenario. And they're feature-based because they talk about the dependency relations of various sorts, correlational, causal, counterfactual, or contrastive example-based between some relevant and important input features and target features. But in addition to these feature-based token explanations, there are also design explanations that very much impact, at least partially, the understanding for why a particular prediction or a decision is made when this algorithmic system reasons. So these kinds of explanations roughly provide reasons in terms of design elements according to which the algorithm learns and reasons. So we can think about them in different ways. One kind of design explanation is representational explanation. So the rejection recommendation is partly because Nora has been represented and perceived in this particular way by the algorithm. So if Nora has been, for example, perceived in with respect to a different set of features and longevity at her work was not relevant or was included into some other features, then the algorithmic output would have been different. Another cluster of design explanations are training data explanations, again, depending on the size and the inclusiveness of the data set. The algorithm would learn different things and therefore would predict different things about new inputs. So the training data explanation can say that the rejection recommendation is partly because the algorithm has been trained in this particular way by the algorithm. In addition to that, there are a host of mathematical and optimality explanations that basically refer to all of those design features, that mathematically designed features, statistically designed features, and loss function choices, and etc., that define how the system actually is really reasoning. So one example could be like the rejection recommendation is partly because the algorithm has been designed to reason according to this specific mathematical and optimality consideration and setup. If the algorithmic if the mathematical and optimality setups were different, algorithm might have been trained to think differently. So, for example, if the algorithm has decided to learn in an unsupervised way as opposed to an supervised way, the result would be different. In the paper, I talked about a couple of cases where these two setups, mathematical and optimality setups, generate different outcomes. So I won't have time to talk about that, but if you're interested, refer to the full manuscript. Okay, now putting all of these discussions together, we end up seeing a pluralistic picture of different kinds of artificial intelligence explanations. And basically, the main motivation is to say that design features or design elements and feature-based token information, like each of these partly say why an algorithmic outcome is obtained, or each of them partly say why a particular algorithmic prediction is made the way it is made. And the goal here is not to say that all of these explanations should be given to all audiences. This is a topic that I turn to now and in the talk. But the goal here is to acknowledge that there are all these different kinds of reasons, and each of them partially, if they are true, of course, capture why a particular prediction or recommendation by an algorithm is made. Now, the functional value of these explanations, again, depends on the audience or stakeholders of the explanation. So explanations at the end of the day are useful if they are interpreted and judged against the relevant vantage points and different values. The questions of from whose perspective the explanations are good or bad, or satisfactory or unsatisfactory, are very much relevant to what we aim to obtain from an explainable artificial intelligence system. And so what I'm going to argue for is that actually sometimes there is a moral or social mismatch between the background assumption and values that are held between different stakeholders, and this mismatch can result in the disagreement about the usefulness of an explanation. And these stakeholders here even can include an algorithm. So interpreting and understanding an explanation therefore presupposes some implicit assumptions and values. So audience X, for example, in context C, understands why a decision is made based on some background assumptions. Now, there are many different kinds of value judgments made. I don't have time to go through all of them. I'm going to talk about two examples. The first is related to representational explanations. Just a broad picture. The idea here is to say that each of the kinds of explanations that I talked about so far, connect or reveal or require some kinds of value judgments in order to be accepted or unaccepted. Sometimes ontological, epistemological, and measurement assumptions and biases impact the assessment or the quality or the relevance of representational explanations. The source, size, inclusiveness, and views about inductive risk arguments also impact the assessment of training data explanations. Again, not much is left to talk about this in details, but please refer to the paper. So putting all of this information together, I introduce now this philosophically informed framework for explainable artificial intelligence. Here we have a set of reasons, different kinds of explanations that I talked about. Then the idea is that each of these explanations should be assessed with respect to different value judgments and background information. And not all of these explanations are relevant to all kinds of stakeholders. But again, because discussions of explainable AI relate and have and finds in many contexts this social, ethical, and legal dimension, it's very good to specify which explanation is good for each stakeholder. And sometimes a conversation actually between the stakeholders is required in order to think about what we want in a specific context from an explainable algorithm. Okay, so in sum, I have talked about truly opaque artificial intelligence systems, that they have sometimes the potential to detrimentally affect lives, and explanations for why such predictions are made deserve considerable attention, in particular in the context of explainable AI. I propose a philosophical framework, reasons, values, stakeholder, to make this clear. And I can propose a couple of ways for future work. So, for example, using this framework for designing experiments for the human in the loop evaluation of acceptability of different artificial intelligence explanations. Thank you very much for your attention, and I'll be happy to talk to you about any questions or concerns you have about the talk and about my paper.